Alright, today we're going to go through our notes on curved mirrors. Now, if you didn't see the notes on flat mirrors, that's okay. Keep watching this video, do the curved mirror stuff, and then go back, watch the videos on flat mirrors. So, with curved mirrors, what curved mirrors are really going to do is a curved mirror is really just a part of a circle. You can see here's our curved mirror right here. And a curved mirror is really just an entire circle, if you can imagine that's a circle, and they just cut out a part of a circle, and that is the curved mirror surface. So we have a few letters here on our axis right here. The C is the center of curvature of that circle that makes the curved mirror, and this F, that is the focal point. So the focal point, and that is listed right here, the focal point, that's where light that comes in from far away is going to be focused. So if you have light coming in, say from up here, this is a ray of light, hits the mirror, let's drag it down a bit so it actually makes contact with the mirror surface. That light gets redirected to the focus. Same thing if you have light coming on the other side of the mirror down here. As long as it's coming in straight on, it's going to be focused to that focal point, which is sometimes called a focus as well. Now, when dealing with a curved mirror, we split up a curved mirror into really 3 different zones. And that's why we've labeled our different areas where we have our focus, F, our center of curvature, C, because anything further away from the mirror than our center of curvature, that's going to be zone 1. So zone 1 is this whole area beyond the center of curvature. Zone 2 is in between the center of curvature and the focus. Zone 3 is between the focus and the mirror. And lastly, behind the mirror is going to be what we call zone 4. Now, an object placed in any of those 3 zones, any of those 4 zones, I should say, will have different impacts on what exactly happens with the image. When you have a flat mirror, imagine looking at yourself in just a mirror, say in the bathroom. Flat mirrors don't really distort images very much. If you look at yourself in the mirror, if you're 6 feet tall, your image is 6 feet tall. If you are standing 2 feet away from the flat mirror in the bathroom, your image is 2 feet away from the mirror. You are right side up. Whereas when you have a curved mirror, you might have noticed if you've ever been in a fun house or looked at yourself even in, say, a spoon acts as a curved mirror. When mirrors are curved, they can make the image bigger or smaller or right side up or upside down. There's lots of different combinations, and what exactly happens to the image depends on which of these 4 zones you are in when the image is created. For 2 different types of mirrors, really all mirrors that are curved in this kind of way. A converging mirror is also known as a concave mirror. I like to think about it as the side of the mirror that the light is hitting is actually this side that's kind of caved in on itself. So let's have some light rays coming in. We have a few different light rays coming in from different points. All of those light rays, they are going to be focused to our focal point, also known as the focus of the mirror. So all the light rays, as long as they're coming in horizontally, they will all get redirected to the focus. They will all converge at one point. That's why we sometimes call a concave mirror a converging mirror. And again, that is when the shape of the mirror is kind of like a cave, right? It's almost like you're entering the entrance to a cave. The light is coming into that cave entrance, getting converged, getting turned in the direction of the focus, all at one point. A diverging mirror, it's still the same shape. It's still just like this, just kind of a cutout of a circle, but instead of the light coming into the cave, right, that would be a concave mirror, the light is instead going to hit the other side. Let's make sure that's a straight line we have coming in. So if you have light coming from very far away, it's going to all be coming in horizontally. Now, our curved mirror, it still has a focus. That focus is always on the concave side of the mirror, but here the light's hitting that convex side, the opposite side. And instead of turning all the light towards the focus, like we had up here with our converging mirror, when the light came into the concave side, if the light hits the convex side of the mirror, it is going to be sent exactly opposite and away from that center, that focus. So the light goes directly away from the focus. And we can just be careful to draw in straight lines exactly away from the focus as best we can. So that's a convex mirror or divergent. It diverges the light. Now on to how to draw ray diagrams with a curved mirror. There are two rules you need to follow, and really it's for these two distinct rays. The first ray that you will draw whenever you have an object is you will draw in a ray that is horizontal then through the focus. And you will do that in the exact opposite order. So let's try this one first. So we have an object in zone 1. Recall zone 1, that is anything beyond our center of curvature. So over here is zone 1. In between center of curvature and focal point, that's zone 2. Zone 3 is between the mirror and the focus, and then zone 4 is behind that concave mirror. Let's change this, make that a bit of a better Z. Okay, so the object's in zone 1. Generally, when doing optics, we like to just use arrows, because they're nice and simple. It's easy to tell if an arrow is right side up or upside down. So we draw in our arrow. This is our object. And we're drawing it in zone 1, so past that center of curvature C. We will draw in a horizontal line. Usually we'll just pick the top of the arrow, the top of the object. Pick one point on your object, we'll pick the top, and we'll draw a horizontal line all the way until it hits the mirror. We'll add in a little arrow to indicate that this light is moving to the right. It's moving towards the mirror, hitting the mirror surface. So it goes horizontal, and then after it hits the mirror, it's going to bounce through the focus. Any horizontal light ray coming into contact with our concave converging mirror is going to be sending the light through the focus. So it comes in horizontally, it must go through the focus. So we can draw in that second ray from where it hit the mirror, right here, bouncing through the focus. We need two rays of light to actually create an image. So our second ray, ray number 2, is going to be through the focus, then horizontal. So let's do this in, say, purple. We're going to start at that same point. Make sure you start at the same point, the tip of the arrow. Draw through the focus until you hit the mirror. Be careful with this. Make sure you line it up nice and precise. Through the focus. That's our first step. And then we're just going to bounce off the mirror in just the opposite way that we did before. Instead of going horizontal and then through the focus, we're going through the focus and then bouncing off the mirror horizontal. Just like this. Now, this point right here, where those lines converge, where they come together, where they meet, that is where the image forms. And that is actually going to be where the top of our arrow is in our image. So we'll connect that down here. This is going to be our arrow image. And you can see there's some characteristics. We talk about these lost characteristics of an image. So let's talk about that acronym really quickly. The object. Where was the object? Well, the object was in zone 1. What does that mean for our lost characteristics? Well, the L in lost, that stands for the location. Where is the image located? Well, it's between our center of curvature and the focal point, so it is located in zone 2. That's our location, that's our L. O is the orientation. Is it right side up, or is it upside down? Well, it is upside down. S stands for size. Is it bigger, smaller, or the same, well, you can clearly compare the two arrows and see that, oh, that image, the one in zone 2, that is smaller. And T stands for type. There are two different types of images, real or virtual. When light rays are actually converging, when you have solid lines converging to one point to form an image, it is always going to be a real image. Another way to tell is that if the image forms on the same side as the object was from the mirror, then it's going to be real. What would be a virtual image? Well, let's talk about that in our next example. If the object is in zone 1 or zone 2, I'll tell you right now, you are going to form a real image. But in zone 3, things get a little bit tricky. Let's imagine we have an object in zone 3. So let's just draw in our arrow. Nice straight line, not too tall. We'll draw in our arrowhead right there. Okay, we are now in zone 3. So what's going to happen? How are we going to draw this? Well, our first light ray isn't too terrible. We can still draw in from the tip of the arrow, horizontal, hit the mirror. Oh, let's make sure we have a straight line. There we go, horizontal, hit the mirror. The light is going from the arrow to the mirror. Then we know it starts horizontal and then bounces back through that focus, just like this. Okay, that's all well and good. But what about the second line? Going through the focus and then bouncing horizontal. Well, we can't draw a line from the top of the arrow through the focus like this. That's not going to work. What we want to do instead is actually start at the focus and use this to guide us. Now, I do want to stress here, as we're drawing this out, the light isn't actually coming from the focus. We're just saying that if you imagine light coming from the top of this arrow, some of it is traveling in line with the focus. And as long as it's traveling in line, in a straight line, from the focus to the mirror, then that light is going to bounce out horizontal. So let's grab our same color, and let's draw in our line horizontal from the mirror, just like so. Let's make sure it snaps into place. There's our arrow. Okay, and for completeness, we could even get rid of this part of the line, because there's not actually light coming from the focus. That light is coming from the tip of the arrow. It just happens to line up with the focus. So we just use that as a tool to draw in a nice straight line from the focus to the mirror, and then out horizontal. So we've done our two rays, right? Remember, you always have one that's horizontal, then through the focus, and the other one that is through the focus and then horizontal. But here, when the object was in zone 1, the light actually converged to a single point. That's where the image formed. That was nothing too crazy. How does this form? The light is diverging. The light is moving away from itself. These lines, they'll never line up. But if you extend these rays of light beyond the mirror, they will actually converge. What do I mean by that? If you are standing over here and you are observing this light, your eye would trace this light back in a straight line path all the way into the mirror and say, oh, this light is traveling in a straight line. It must have come from over here. So let's go ahead and extend this line deep into the mirror. And now when we do this line extension, I talk about this more in our flat mirror video, but whenever you have a ray of light that's not actually existing behind the mirror, our eyes are just tracing that light back, you want to make sure you're making sure it's a dashed line. This is a virtual light ray. The light is not actually back behind the mirror. Light starts at the arrow, bounces off the mirror, and then goes into our eye. But when our eye receives that light, we trace the light back in a straight line path all the way into the mirror. We think the light came from over here, because our eyes say, oh, light must have traveled in a straight line. We can do the same for this red line. And now I tend to struggle
when I'm trying to make a straight line that's already not straight because it just doesn't snap in. So what I'd recommend doing is, let's go ahead and erase this that we started drawing in. I would recommend starting at the focus, this line that we already drew in. We know light is coming in horizontal toward the mirror, then bouncing off through the focus. Start your line at the focus, and this way, see, we have our line here. We can just line up the line perfectly with what we originally drew, making sure it's all nice and straight. And of course, this light, it's not actually coming from behind the mirror. There's nothing over here. The light is bouncing off the mirror going this way. So this virtual light ray, let's make sure to erase. Make sure it's a dashed line, and we know this isn't actually light back here. It's just where our eyes imagine the light is coming from. And we notice those do converge to a single point right here. We can take that point, we can extend it down. This is where our image is going to form. And we can see, okay, well, the object was in zone 3. Let's write down our lost characteristics. The location. It is in zone 4. It is behind the mirror, the image is. What about the orientation? Well, it is right side up. What about S, our size? Well, look at that arrow. That image is clearly bigger than the original arrow, so it is bigger. And let's talk about our T, the type. Is it real? Is it virtual? Well, if we had our solid lines converging to form the image, it would be real. But because we have our virtual lines, our dashed lines converging to form the image, that is a virtual image. With this, what I want you to do, try pages 8, 9, 10, and 11. This is all practice drawing in our curved mirror ray diagrams. I have uploaded a key for these pages, so as you go through, as you try them, please check with the key, see how we draw in our two rays. Again, it's always horizontal, then through the focus, and through the focus, then horizontal. These take practice, but once you get used to them, you'll find them to be not too terribly difficult. My one addition to this is normally we would have done the curved mirror lab before this page. So we always ask you, according to the curved mirror lab, what do you expect for the characteristics? We're going to do the curved mirror lab on Thursday. So instead of filling in your lost characteristics first, do the ray diagram, draw in your image, kind of like what we just did up here, and then look at your image and say, oh, what's the location, what's the orientation, what's the size, what's the type? Check with the key as you go. And then if you missed class before break, if you did not get the flat mirror information, please watch the video linked on Schoology for that information. Also, make sure that you've finished up pages 2, 4, and 5. Next class, we will have a flat mirror check-in, so make sure you are able to draw in your ray diagram for a flat mirror like this.